Welcome to EduPorm India. You're watching Expert Chemistry with Abhinav Gaur. Today in this lecture we will study about the acidity of alcohols and the acidity of phenols. So let's start by understanding the acidic nature of alcohols. In case of alcohols, we have a carbon chain attached to a hydroxyl group. For example, we have CH3OH. So in this case, if I draw the structure like this, then it will be much better to understand. So in this case, we know that the oxygen atom is more electronegative than hydrogen, as well as the CH3 group also show electron donating effect. It is a electron donating group, not a electron withdrawing group. So in this case, if we talk about this case, the oxygen is acting as the partial negative center, whereas the hydrogen is acting as partial positive center. So there is a chance of removal of this hydrogen as a proton, and we know that if proton is released, then acidic character is shown. But what happens, because this attached CH3 group or this attached R group show plus I effect or show electron donating nature, so the electron cloud, or we can say the polarity of OH bond decreases. Okay, so presence of this donating R group decreases the polarity of OH bond, and due to this decrease in polarity, alcohols are weaker acid. They are weaker acids than water, as well as they are weaker acids than phenols. And why so? Because the attached R group show plus I effect. It is a donating group, and because it donates electron to oxygen atom, so the polarity of OH bond decreases and chance of H being released as H positive also decreases. This can be shown by one example of one chemical reaction, which is we have RO negative. These are the lone pair present on the oxygen atom. If this react with water, that means HOH, then what happens is this act as a base, this act as a acid, and we get the formation of ROH, which is conjugate acid, and we get the formation of OH negative, which is conjugate base. So this reaction shows that alcohols are weaker acids than water, as the conjugate base formed is alcohol in this case. Okay, so this is all about alcohols. One more thing that we need to know is, if we have primary alcohol, then primary alcohol is more acidic than secondary alcohol. Let me make the primary alcohol in another way. So this is our carbon atom and only one R group is present. This is primary alcohol. It is more electronegative than the secondary alcohol, and this is more acidic. This is most acidic, then this is more acidic, and the least acidic is where we have tertiary alcohol. And why it is? Because here we have three groups which are decreasing the polarity of COH bond, or we can say decreasing the polarity of hydroxyl group. Here we have two groups which are decreasing the polarity of OH bond. Okay, and here we have three groups which are only one group which is decreasing the polarity of the OH bond. Okay, so in case of alcohol, if we have primary alcohol, they are more acidic than secondary, which are more acidic than tertiary. The more number of donating group are present, the least acidic character will be shown, and the alcohols are least are weaker acids than water and phenols. Now let us study about phenols. First of all, phenols are more acidic than alcohol. This is a common question which is asked, so I'm writing it directly. Phenols are more acidic than alcohols, and the reason is that in case of phenol, the hydroxyl group is attached. In case of phenol, the hydroxyl group is attached to a carbon atom which is sp2 hybridized. This carbon atom of the benzene ring is sp2 hybridized. So this sp2 hybridized carbon act as electron withdrawing group. It withdraws the electron. Okay, so as it acts as an electron withdrawing group, so the polarity of OH bond increases, and because the polarity of OH bond increases, so phenols easily release proton, and as they release proton, so they are stronger acid. The another reason of phenols being stronger acids is that there is partial double bond character, and formation of phenoxide ion is favorable, and this phenoxide ion is more stable. This phenoxide ion is more stable as compared to phenol, as there is delocalization of the charges. So due to the delocalization of charges, the phenoxide ion is more stable than the phenol, and thus the phenol easily releases H positive. Now, one good thing to understand is, if we have three cases, I'm showing three cases. This is case number A, where we have a phenol, and at ortho position NH2, or we can say some other groups which are electron withdrawing groups, are attached. Okay, I'm writing NO2 instead of NH2 here, NO2. And the second case is at the para position. So this is our phenol, and to its para position we have NO2 attached. In both of these cases, the presence of electron withdrawing group, increases the acidity. So this compound is more acidic than phenol. Why? Because electron withdrawing group is present at ortho position. Similarly, this compound is more electronegative than phenol, as electron withdrawing group is present at para position. Now case number 3, if I have a phenol, and to this phenol electron donating group such as CH3 is attached. So in this case, the cresols, the name is cresol. So in this case, the popular case of cresol, the cresol is less electronegative than phenol. And why so? Because electron donating group is present, and because of the presence of electron donating group, the release of H positive ion will not take place. So this is all about the acidity of alcohols and phenols. All you need to understand is the concept of electron withdrawing group and electron donating group. In case of alcohols, electron donating group decrease the acidity. In case of phenol, the presence of electron withdrawing group increase the acidity. Thank you.